reagents, right? So here we have one of the problems from your homework. When I look at limiting reagents, I always address the limiting reagent ratio. So if you look at the reactants, what's the ratio there? Yeah, it's the ratio. Oh, these two, the reactants here. No, it's a, everybody see it's a 2-to-1 ratio. There's a 2-to-1 ratio of the N2 to the O2. Does everybody see that? You might not see that. So what I always do, right, I always take that ratio and I'll divide it by itself. All right, so it's a 2-to-1 ratio. Now, if I'm given a substance, like if I'm given, 500 grams of this and 500 grams of this, let's just say that I'm given 500 grams of N2 and 500 grams of O2. Let's convert that to moles. So you go to the periodic table. 1 mole of N2 is 28 grams. Does everybody see that? Because nitrogen's 14 times 2. And then we have 1 mole of O2 is what? How many grams? 32 grams. So let's divide 500 by 28. I got that for us? Looks like 17.85. That's mole of N2. And then we're going to take 500 divided by 32. That's 15.62. All right, so I'm going to come back over here now, and I'm comparing N2. This is our ratio here, a 2-to-1 ratio. I'm going to do it on this side. So we have 17.85 divided by 15.62. Now, if the number is greater than 2, which one is excess? Like if over here, this is the standard 2-to-1. So if this answer over here is 3, which one is excess? This one is excess, right? Does that make sense? So if you have something greater than 2, this is excess. If you have something less than 2, then this is limiting. Make sense? Because you need at least 2. If you don't have at least 2, then this is going to be limiting. That's how I look at it. I do the comparison. A lot of different ways to do it, but this is the way I do it. So we take 17.85 divided by 15.62, and you got 1.1. This equals 1.1. So this is less than 2, right? Cody, you might want to write this down. Yeah, so this one's going to be limiting. In this situation, this is limiting, and this is excess. All right, you need at least 2 for this to go, and you don't have that. You have like 1.1. All right, so you have more of your bottom one. Now, if you were to increase that and get it to closer to 2, the goal is this right here. This is the goal. That's the balanced equation. Yeah. You never start your reaction with the excess. So over here, I'm not going to run my reaction using N2. I'm going to run my reaction using O2. Wait a minute. Oh, wait a minute. I'll take that back. Because this is limiting, so you're going to go with what's limiting. You always start your reaction with what's limiting. You can't do it with what's excess, because what's limiting is going to prevent you from doing the reaction. So because this is 1.1 and you don't have 2, this is limiting. So I'm gonna do the reaction with the 500 grams of N2. So over here they've told us what's excess, right? We have excess O2. Oftentimes they won't always tell you that. And then you're like, okay, well I'm going to start my reaction with what's limiting. That is the 26.52. What's limiting is going to determine what you can make, because it's limiting. Like if you're baking a cake and you need 3 eggs and you have 2, you can't make the cake. So it's limiting. It's limiting you from making the cake. Make sense? Are limiting. And we're going to use the periodic table to get this information right here. Right, periodic table. And this is coming from the balanced equation. Right here. And then right here. So BE is balanced equation. 26.5 divided by 28 should be a fraction.
Let me just do it right side.
Yeah.
0.9.
Times 2.
No, you don't. Well, you're dividing by 2.
Oh.
See that? So that cancels out to 1.
So it'd be 0.26, right?
Sounds good. Okay, very good. So if you look at the diagram there, you'll see on the first part that we have a lot of different tools, right? The available tools. Then you have sets of tools. Then you have extra tools, right? So the extra tools are going to be considered what? Excess. So remember that when you go to the workplace, you're going to see this there. You're going to have some tools that you don't use, and you're going to have some ingredients that you don't use. You're going to have some parts that you don't use. And typically, you know, after a while, they're going to try to sell those typically at a lower rate. So if you go to, I don't know, sporting goods like Academy Sporting Goods, they'll have the clearance rack. Similar idea. Excess.
Reactants present in the exact ratios specified by the balanced chemical equation. Generally, one or more reactants are in excess, and the reaction proceeds until all of one reactant is used up. When a reaction is carried out in a laboratory, the same principle applies. Usually, one or more of the reactants are in excess.
Products in the production of disulfur dichloride, molten sulfur reacts with chlorine gas according to the following equation: SA1 plus 4Cl2.
What determines how much product you can make? If a carpenter had 2 tabletops and 7 table legs, he or she would have a difficulty building more than one functional 4-legged table. Working for Yum, Taco Bell. To make tacos, you need enough meat, cheese, lettuce, tomatoes, sour cream, salsa, and seasoning to make your tacos. If you don't have one of those, guess what's going to happen? The customer is going to get upset because they want them on there unless they say they don't, right? So you have to prepare the recipe so the customer is happy. So you're determining the limiting reagent, right? And what do you want to look at, Lily, when you're trying to determine the limiting reagent? What are you trying to examine when you're determining the limiting reagent? The recipe. The recipe.
Okay.
So when you go, let's say, to any restaurant or any place that you're working as a manager, you need to know what the previous sales were. That would be the recipe. If you don't have the recipe, you're probably going to go out of business. Most restaurants fail in their first year because of management. Most businesses fail because of management. Sears. If you'd asked like 50 years ago, Sears would be where they are today, most people would say no way. Because they used to sell everything. Sears used to be the Amazon of like consumer products. They would sell, they had these books they put out, like magazines almost, where you would buy from them, mail order. So they were really big into mail order, Sears was. And it was kind of interesting that Sears kind of understood the power of mail order and why they didn't implement that in their marketing strategy for the future. They just kind of fell away from it. I guess they thought the department store would be more important, but it obviously wasn't because it put them out of business. So up here we have the recipe. Now when you look at the recipe, you're really only concerned about the reactants. What's the ratio here? Yeah, it's 2-to-1 ratio. Does everybody see that's a 2-to-1 ratio? That's what I go to at the start. Just find out what the All right, so this example comes from the book right here, page 380. You have S8 plus 4Cl2 yields 4S2Cl2 right here. And we notice that the ratio is a 1 to 4. If this value increases, it's going to go to 0.5, and that would be excess if this increases. So they're given, in the book, they gave us 100 grams, so that's 1.410 moles Cl2, and 200 grams, so that's 0.7797 moles of S8. Does everybody see that?
Yes, I see it.
Now what you're going to do, you're going to compare it to this. So I want to put my S8 on the top. So I'm going to put 0.7797 mole S8 divided by 1.410 mole Cl2. So let's do our math. 5, you must have more of this in order to get 0.55. In order to drive the 0.25 up, you must have excess of this. So the S8 is excess, so I'd write that there. And I'm going to circle this as limiting. That's what I care about. That's what I'm going to use to predict what you can make. This equation is 2 to 1. You have 2 of the nitrogens. That's 14 times 2 from the periodic table. Oxygen 16. You have 2 of them. So we're going to take 2,000 divided by 28, and we're going to get the moles in 2,000 grams. And that is equal to 71.42. And then we have 1,000 divided by 32. And that is equal to 31 moles of O2. So write that down for the periodic table. We do our ratio, and the answer is 2.2. Now raise your hand. Amani, you're supposed to be writing this down.
I am sort of.
Pay attention.
So we're talking about management. That is, many of you will be in a management position in the future. Isabel, you might want to write this down. So you can see that the ratio from the balanced equation is 2. 2 divided by 1. That's the ratio. That's the standard. You're above that. So this is excess. The only way to drive the standard higher is to have more of it. Now we care about what's limiting. We don't care about what's excess. Why? If you're going to bake a cake and you need 3 eggs and you only have 1, guess what? You're not going to be baking a cake.
Potassium permanganate was the limiting reactant, as the name implies. The limiting reactant limits the extent
Product you can make in a chemical reaction. Raise your hand. See that? The balanced equation. So we've converted our example here to moles. We have 1.25 moles of Cu divided, correction, and 0.78 moles of S. Now I want to divide the two. I want to divide this. 1.25 mole of Cu divided by 0.78 mole S. So I want to get my ratio comparison to this. So if I do that, 1.25 divided by 0.78 equals 1.6. Does everybody see 1.6 is less than 2? So what is excess? Which of these two is excess, the 2 or the 1? The 1 is excess. The sulfur here is excess because we don't have 2 here. We have 1.6. The only way to get 2 lower is to give more of this. Does everybody understand that? If you have a 2-to-1 ratio is a 2, and you have a 1.6 over here, the only way to get this number less is to have more of this. That's going to drive this 2 down. So this sulfur is going to be excess. So we're going to have 0. Now that's important. I usually I will circle the excess and label it. And then I'm going to box in my limiting. The limiting is important because that's what you're going to use to solve the problem with. It's kind of like if you're at a restaurant, you need to know what you're going to run out of. So you're aware of the customer, you can kind of steer them away from buying certain things if you know you're going to run out of it. Because you don't want to upset the customer, right? You might say, that's not something that I really like. Don't order that dish if you know you're running low of it.
Excess, and the reaction proceeds until all of the one reactant is used up. When a reaction is carried out in the laboratory, the same principle applies. Usually 1 or more of the reactants are in excess, while 1 is limited. The amount of product depends on the reactant that is limited.
All right.
A portion of all other reactants remains after the reaction stops. Reactants left over with the reaction stops are excess reactants. To help you understand the limiting and excess reactants, consider the